Hello everyone, welcome back to our biology learning series. Today we are going to understand an extremely important topic from neurobiology, the mechanism of nerve impulse conduction. A nerve impulse is an electrical signal that travels along a neuron. This allows us to think, move, feel pain, and respond to our environment. When a neuron is not transmitting any impulse, it is in a resting state, known as the resting potential. In this state, the outer surface of the axonal membrane is positively charged, and the inner surface is negatively charged. This difference is the resting membrane potential, typically about -70 millivolts. This potential difference exists because sodium ions are more outside the neuron, and potassium ions are more inside. The sodium-potassium pump actively maintains this ionic difference. Next, let's look at what happens when a neuron receives a stimulus, leading to depolarization. When a stimulus arrives, voltage-gated sodium channels open, causing sodium ions to rush inside the neuron. This sudden inflow of positive ions makes the inner surface positively charged. If the stimulus reaches the threshold potential, an action potential is generated and moves along the axon. Immediately following depolarization, the process of repolarization begins to restore the resting state. The sodium channels close, and voltage-gated potassium channels open, allowing potassium ions to move out of the neuron. As potassium moves out, the inner surface becomes negative again, and the membrane returns toward its resting state. If too much potassium leaves, the membrane becomes even more negative. This is hyperpolarization. During the refractory period that follows, the neuron cannot fire again, ensuring that impulses move in only one direction. In myelinated nerve fibers, the impulse jumps from one node of Ranvier to another. This jumping movement, called saltatory conduction, significantly increases the speed of impulse transmission. To conclude, nerve impulse conduction is a cycle of resting potential, depolarization, and repolarization, driven by ion movement. Remember, myelinated fibers use saltatory conduction for speed. Understanding this is key to mastering nervous system physiology.